All right, if you remember the very beginning of this graphing unit, we just looked at graphs and found their periods. So that's all we're going to do to start here, since so many of our AP questions require this skill. So try to find the pattern first of all, and we might identify it in different places. But the idea is that you start and stop at the same output. You have to hit the minimum and up to the maximum values on the graph. And then the pattern repeats that same shape that you marked off. So I'm going from -10 to 10. That's a distance of 20 units. So that is the period, 20. And that would be 20 radians for this particular graph. For number 2, this pattern, it looks like we have these little sections here, and then there's a big gap, and then another section. So pick any one of these 3 sections, and to find the distance, just subtract the 2 values that you're going between. It's always the second minus the first. A period is a distance, so it's always positive. So 13 pi over 2 minus 11 pi over 2 is 2 pi over 2. So that's a period of pi. For number 3, so I'm seeing this. We've got 2 of these humps here, and then it goes down. And then that pattern repeats again. So the second part is kind of off of my grid. So we kind of need to rely here. Or maybe you started on -3 pi and stopped at -pi. That might be a little bit easier to look at since that number got cut off. But either way, that's a distance of 2 pi, right? Each set of humps is pi units. So that's a distance of 4 pi. Oh, I'm sorry, 4 pi all the way across. I don't know if I misspoke earlier. So we're looking at going from -pi to -3 pi. So -pi minus -3 pi. So sorry, what did I say? 4 pi. I meant 2 pi. Each one is pi across, right? This is pi and this is pi, just to confuse you even more. So the period here is 2 pi. I think I was looking here saying this is going to be -4 pi. All right, and then last one. Now this is sort of a preview to what we'll be doing down the line, but this is some sort of a tangent graph. This is what the tangent graphs look like. So something to look forward to here. And there are these gaps, like there are vertical asymptotes here. You don't necessarily need to know that, but it's kind of nice to mark off where this is just to see what are those x values that the graph is falling between for each one. So whether you look at that first branch or the second branch here, we need to figure out where we are. So looks like this is 1.5 pi or 3 pi over 2, and this looks to be 4.5 pi. So what's the difference between 4.5 minus 1.5? That is a difference of 3. So this has a period of 3 pi. Same thing here. This would have been 7.5 minus 4.5 pi is, again, 3 pi. All right, now the rest of our quiz, most of our quiz, will be sketching. So we're going to start off with some basic graphs, and then we'll ramp it up to the end where we have all of the transformations. So sketch the graph for each function across the window. Make sure you're filling the window. Most of you have been doing that for your homework, but some of you have only done a period or 2. So fill the whole thing, and then find all of the information. So starting with the sine graph, this has an amplitude of 3 because of the number out in front. Period of 2 pi, because the formula is 2 pi divided by b, and there's a b equals 1 in front of x. Domain and range I do after I graph. And I also like to just remind myself what a positive sine curve should look like. So it's midline, above midline, midline, below midline. How far above midline is the amplitude, this distance? All right, so this one, mark off the period. Cut that in half, put your marks in. So these marks represent where I'm going to be placing these points. Helps me visually. So the sine graph starts at 0, 0. It reaches its amplitude at pi over 2, so up to 3, back to midline, down to -3, back to midline. This is one period. Now continue this pattern. So you can see you're plotting points every one box. So just continue the pattern every one unit. So above, midline, below, midline. You can carry that on to the left, or if that tends to mess you up, like whether you go up or down or whatever, you can start on negative 4 pi. That's like your new y-axis, and say, okay, go above, below, or I'm sorry, midline above, midline below, midline above, midline below. Or if you were going from 0, you would have gone below first, midline above. So either way, you should get this nice looking sine curve. And we're doing our best to make it a smooth curve, not too sloppy. The taller the graph, the harder this is, I understand. So just do your best. And we put arrows on the end to indicate that this pattern will continue on. So what about domain and range? If it's just a sine or a cosine graph, there are no vertical asymptotes, no holes, no jumps, no skips. So all real numbers for the domain. And the range is affected by the amplitude and any vertical shifts we have. So the amplitude made the range -3 to 3. By default, it's -1 to 1. All right, next one is a cosine curve. So this one has an amplitude of 1/2. The period is 2 pi divided by 2 because of the b value in front of x. So that's a period of pi. And there are no shifts to worry about. A cosine graph, a positive cosine graph, begins at its amplitude, then midline, negative amplitude, midline, amplitude. So here we need to divide the period into 4 parts. So mark off the end of the period, which is pi, cut that in half, cut that in half. That's going to be pi over 4, by the way. And then put another little halfway mark. Are you required to label your axis? No, I just want you to know what these points are. Our next unit is going to be look at a graph and write the equation. So we might need to figure out what some of those in-between points are that are unmarked. So pi over 4, pi over 2, 3 pi over 4. Basically, though, we should just be putting points every half unit. So if you need to tick off every half unit to remind yourself of that, you can. Otherwise, sketch in your cosine graph. So its amplitude is only 1/2. So start at 1/2 on the y-axis. At pi over 4, hit midline. At pi over 2, hit -1/2. 3 pi over 4, midline. Back to 1/2. And so, again, if you can keep track of it visually, then just every half unit. Midline, below, midline, above. This is what I'm saying in my head, too, right? So midline, below, midline, above. So get yourself into a pattern or a rhythm when you're doing this for a quiz, and it makes the process a bit faster. What if we go off to the left? So from above, we go midline, below, midline, above. Midline, below, midline, above. Midline, below, midline, above, and just continue that every half unit. Your graph should start and stop where it ended every time you do a little period. And this is a cosine graph, so we will connect these points. Again, I know it's hard, especially with so many, to make it a smooth curve, but just do your best. When we have a quiz over this, it's not going to be, 20 of these graphs to do at once, so you're going to have time to make them kind of nice looking. And do remember to put your arrows on the end. For a cosine graph, the arrows have to be curving down. I'll dock a little half point or something if you have it shooting up, because that's inaccurate. The cosine graph does not reach past +1, so be careful with that. And then domain and range. It's a cosine graph, so all real numbers. And the range goes from -1/2 to +1/2. All right, our next graph is a cosecant graph, which means we should be thinking about a -2 sine of x over 2 graph. So I'm going to be thinking about a negative sine graph. So 0 below, 0 above, 0. The period is, I don't have amplitude marked, by the way, because cosecant doesn't have an amplitude. Amplitude is what's the distance between the x-axis and the absolute max or absolute min. And the cosecant graph doesn't have an absolute max or min because it goes to infinity plus and minus. Anyway, period is 2 pi divided by 1/2. That's the b value. So that's really 4 pi. So let's divvy that up. 4 pi, cut that in half, 2 pi, cut that in half, pi, and then go over and make your third tick mark, which would be at 3 pi. And maybe I do that to the other side too, just so I have those marks in. All right, so it's a -2 sine graph that I'm using as my stencil. So start at 0. At pi, your first tick mark, you're going below the midline by that sine graph's amplitude, so by 2. And then back to 2 pi, up to 2, back to 4 pi 0. And then on the other side, at -pi, we're at 2, then midline, -2, midline. So the sine graph is here. You don't have to dot it in. You can if you want to. Anywhere the sine graph hits 0, we put in a vertical asymptote. Because anywhere sine is 0, cosecant is then undefined. And then you need to draw in the branches of the cosecant graph. So the branches of the cosecant graph share the relative maximum points, and the branches open away from your midline. Because remember, anywhere that you're in that midline, that's where the cosecant graph would not exist. So we get these 4 branches. We sketch them about as wide as the asymptotes so that we're not sketching little tiny things like that. We want to get semi-accurate with these shapes. What's the domain for this? So you're saying all real numbers except where are those vertical asymptotes? So you can see the pattern. We've had kind of the same few handful of vertical asymptotes. It's happening every 2 pi. So if I want to say multiples of 2 pi, I say 2 pi k. And remember to either write out the words, k is an integer, or you can use this little shorthand. K is an element of the integer number set. That's what that z means. That's the letter that denotes the integer number set. I didn't make the rules. I'm just the relay. Capital I was taken for irrational numbers. Anyway, range is -infinity up to -2 on the bottom branches, and then 2 to infinity. Okay, number 8. So we have y equals 3 secant of x minus 1. So let's think about graphing 3 cosine x minus 1. A positive cosine graph starts at its amplitude, midline, negative amplitude, midline, amplitude. The period here is 2 pi divided by 1, so 2 pi. The midline is y equals -1. Domain and range we'll figure out in a minute. So this has a vertical shift of down 1. That's why the midline has been shifted from the x-axis down 1. So optional, but I like to draw in the midline. We're going to be using the idea of midline to help us write these equations from the graphs next section. So that's why I'm kind of harping on that so much. And then the period is 2 pi. So divvy up 2 pi into its 4 equal parts. And so start this cosine graph. We should be 3 units above the midline. So here's the midline. Start 1, 2, 3 units above that for your cosine graph. The next point at pi over 2 is on the midline. And then 1, 2, 3 units below, you should be down at -4 at pi. And then midline, and then 1, 2, 3 units above. So here's one period. We're placing marks every one box. So continue the pattern. Midline, 3 below, midline, 3 above. On the left side, back to midline, 3 below, midline, 3 above. Midline, 3 below, midline, 3 above. Anywhere the cosine graph hits the midline, those angles are places where cosine equals 0. So that means that we need to draw a vertical asymptote for where secant is undefined. You're welcome to use colors when you're doing these. Pencil is best to get yourself started, though, in case you make a mistake. But if these kind of make your eyes buzz to figure out what's happening, some people use highlighters and things. And then remember that each branch opens away from the midline. And the secant graph does have these little half branches on the ends just because of the behavior of the cosine graph and the period that we graphed. So I do want you to include your entire window graph. So if there should be even a little half branch at the end, make sure you do that for a quiz. So here's my other little half branch. What's the domain for this one? So all reals, x is not equal to. So let's take a look at these. Pi over 2, 3 pi over 2, 5 pi over 2. It's all the odd pi over 2s. It's not pi over 2 times k because that would include the pi's as well. 1 pi over 2, 2 pi over 2, 3. So remember, you can get these by saying start at one of the asymptotes. I usually start at the first positive one, pi over 2. Add to that the distance between asymptotes. So it's easier to see on positive to negative. This is a distance of pi, or like 3 pi over 2 minus pi over 2 is 2 pi over 2. So you're a distance of pi away. So if you add pi to the first asymptote, you land on the next one. If you add 2 pi, you land on one that's 2 away, or if you subtract 2 pi. So make it plus pi k and make k an integer. All right, and then the range is negative infinity up to negative 4 for the bottom branch and 2 to infinity for the top branch. All right, making these a little more challenging. So we're back to a sine graph. So a sine graph looks like midline above, midline below, midline. We've got a little work to do on this one as far as rewriting so we can see the amount of shift to do. So factor out a 1/2. Make this x minus, so if you're factoring out a 1/2, you're dividing pi over 4 by 1/2. So that's pi over 2. If you're a little shaky on that math, then double check if you were to distribute the 1/2 back through, you would get x over 2 minus pi over 4 if you were to take that back through. Amplitude is 1. Period is 2 pi divided by 1/2, so 4 pi. Shifts, we're going to the right, pi over 2. So that's the phase shift. Now, I like to divvy up the period first. So cut 4 pi into 4 equal parts. And then if you're going to shift everything right to this starting line, which is really the y-axis, I like to start it at pi over 2, like this. So I'm shifting that to the right, pi over 2. And then that's actually going to shift all of my tick marks, right? So I marked off the period here, but really, maybe I should have done the shift first because think about this. So, let's have these in. Let's say we had these in. All of those tick marks have to get shifted to the right pi over 2 units. So really there's going to be a point at 3 pi over 2, and 5 pi over 2, and 7 pi over 2. And we don't have to take it out further, but 9 pi over 2. Okay, and then once I get that pattern in my head, once I get one period graphed, I'll do the other period. So the sine graph should start at its midline. So starting at pi over 2, 0. And then the next point, remember there's pi units between here. So the next point is at 3 pi over 2, and you go up to the amplitude. And then at 5 pi over 2, we're back to midline, negative amplitude. And you don't have to connect back to 9 pi over 2. I'm just going to, just to finish it. Okay, so then what does that mean? Basically, when I do the rest of it, I'm thinking like, well, how many boxes are between my points? So you're plotting points every 2 boxes. So maybe you want to mark off just every 2 boxes where that's going to fall. Okay, so the next point from here goes at negative pi over 2 goes down to negative 1, back to midline, up to 1, midline, and then the graph will go down from there. Okay, so here are 2 periods of my sine curve. So that one was a a little bit trickier, right? A little more thinking involved. So say we just stop it there, and then what about here? I just want to make sure the graph doesn't go, like I don't want to draw it like that, because the next point should really be like over here. So it's kind of nice to give yourself something to aim for on the other side, but just something like that. What's the domain and range? We're back to all reals because it's a sine graph, and the range here is amplitude -1 to 1. It's just been shifted a little bit. All right, what about this one? So there's nothing to factor out here, so that's good. The amplitude is the absolute value of -1, which is 1. The negative is there to act as a x-axis reflection. So the negative cosine graph starts at the y-axis, and then it goes midline up, midline down. The period is 2 pi divided by 1. The shifts are left pi and down 3. So we did this in our notes. I like drawing a new midline, and I like drawing a new starting line too. So let's do that. Left pi should be new starting line right here. Down 3 should be all the way down here. So it's kind of like your new origin. Your new origin is right down here at -pi, -3. And then the period was 2 pi. So I guess, how are we going to divvy this up? So normally it would be here, right? We plot points every one box. So you can still just take those tick marks and say, okay, plot points every one box here, and get yourself a negative cosine graph. So start 1 unit below your midline, and then midline, 1 unit above, midline, 1 unit below. Now that I have the pattern, I'm just going to carry it on. I should be marking a point every box, and I just continue. Midline above, midline below. Midline above, that's where that stops. Continue to the left. Midline above, midline below, midline above. This is a cosine graph, so no asymptotes. Just connect the curve together with a nice smooth curve. Got a little crazy there. I'm going to redo that section. There we go. You want to make sure you're not making these look linear. Everyone's homework graphs have looked pretty good so far. You want them to have a bit of concavity to them. And remember, for cosine, to make it curve back down at the end. Domain and range. So domain is all reals. Range, this graph got shifted down, and it has a 1 amplitude, so it's going from -4 to -2. All right, last two graphs. We're ending with a cosecant and a secant. So if it's cosecant, let's think of it as -2 sine of x over 2 let's factor out our 1/2. 1/2 x plus pi plus 1. If you factor a 1/2 out of pi over 2, just like when you factored it out of x over 2, you're just going to be left with the pi. You can redistribute that to double check, but that's right. The period is 2 pi over 1/2, so the period is 4 pi. For the shifts, we have a phase shift, left pi, and we have a vertical shift, up 1. So, and then let's remind ourselves, a negative sine graph goes midline down, midline up, midline. All right, so let's give ourselves our new starting point. Now remember to be careful with the starting point if it's cosecant or secant. We talked about this in the notes. If you draw a full vertical line, it might look like a vertical asymptote, and it may or may not actually be one. So how about we do this? We're going to go left pi, and I'm just going to give myself a little mini one like that. That's my starting point. And then we're also going to go up 1, so I guess like this. I do want to graph all the way across. I like having the midline go all the way across, and that's not going to confuse me for asymptotes. But I'm just saying, where this may or may not be an asymptote in the end. So okay, so that gives me enough for my starting point. And then what about this 4 pi thing? So normally the period would be at 4 pi, cut it in half, cut it in half. So what this tells me is we should be plotting points every 2 units. So now that I've shifted everything a couple of units over, the starting point is going to be at this new like 0, 0 at negative pi 1. And then from there, the next point should be 2 units over, which is, excuse me, which is pi units over. All right, so this negative 2 sine graph will start here at the midline. And then the next point, which is 2 units over, pi units over, will be 2 units below the midline. And then go 2 more boxes back to midline, and then 2 units above midline, back to midline. So we have this as our first period, and then following the pattern, 2 units below. On the left side, I should be 2 boxes over, 2 units above, midline, 2 below. All right. Now, in this cosecant graph, and this will always be the case for cosecant, that starting line is where we're on the midline. So, and that's how it always is for sine. So yes, this was a vertical asymptote, but just to be safe, I kind of like to make it just a little mini one to give myself a starting point. So we have our vertical asymptotes in. Draw in the branches that open away from the midline. So there's a little half branch there. So the half branches are not reserved for just secant graphs. It's all about just in our window that we're viewing where the window cuts off. It's not that a secant graph should have to have half branches or a cosecant shouldn't. They would be complete branches if we expanded this window out further. So there's no stopping point to this besides our window constraint. So what is the domain? All reals. X is not equal to. We're at pi, 3 pi, negative 3 pi. This is all the odd pi's. So that means pick your starting point. I'm going to say pi is my starting point. How far apart is it from pi to the next asymptote on either side? It's 2 pi. So add 2 pi to that and do that k times. You can add any amount of 2 pi. So you could add 4 pi or 6 pi or whatever, and that will land you on another asymptote. So as long as k is an integer. The range is negative infinity up to negative 1 and positive 3 to infinity. And that's because we had an amplitude of 2, so that's why I was doing the points above and below 2 units. Okay, last graph. Last graph here is a secant graph, so we should be looking at this as negative 1/2 cosine of nothing to factor out, x minus pi over 2 minus 3. So I'm going to remind myself that a negative cosine graph starts below the midline, midline above, midline below. The period here is just 2 pi. There is a phase shift to the right, pi over 2. And there's also a vertical shift, which is down 3. And we'll do domain and range once we get the thing graphed. So let's draw in our right pi over 2 and our down 3. So our new y-axis, let's just do a little mini. Let's do down 3 first. How about that? Down 3. So here's my midline. And then pi over 2, it's like, okay, this is your new starting point. Let's just do a mini one because we don't know if this is an asymptote yet. It won't be for secant. Because what does the secant graph look like? Well, I'm marking off 2 pi. So remember, 2 pi is when you're plotting every box. So from this starting point, I should be plotting a point every box if I shift everything to the right pi over 2. Okay, so the cosine graph starts at its amplitude below the midline. So we're going a half unit below the midline, and then 1 box over, we're midline, then half a unit above the midline, midline, half a unit below. So see how this, at this starting point, this is not a vertical asymptote. You might want to erase the little bit that you have now that you have this started, because you don't really need the starting line anymore. And you don't want to get it confused with a vertical asymptote when it's not. So we did that in our notes too. Continue the pattern on. Midline, half a unit above, midline. Then on this side, midline, half a unit above, midline, below. Midline, above, midline, below, midline. Put in vertical asymptotes anywhere the cosine graph hits its midline, because that is where, if you plug in those angles and you do cosine of that angle minus pi over 2, you get 0. And then when you take the reciprocal of 0 around the unit circle, you get undefined. So that's why we have all these vertical asymptotes. Right. And the last thing is to draw in the branches. So make them open away from the midline and fit them to the width of your vertical asymptotes. Make sure you're putting arrows on these. It's easy to get annoyed with this and do it kind of sloppy and rushed, but try to resist that and just get this last few filled in nicely so that you don't do it in a poor way to lose points on your quiz. Okay, so that's pretty good. And then what's our domain? All reals, x is not equal to, so it looks like they're at every pi. 0, pi, 2 pi, 3 pi, 4 pi. So that's easy. That's pi k. K has to be an integer, k's. And negative infinity up to, now what is this? This is negative 3.5, so be careful there. And then this is negative 2.5 up to infinity. Now I'm not extending these, but these branches do extend all the way up, right? If you were to graph this in Desmos or something, you wouldn't see all the dotted lines I have. You would just see these extreme branches. All right, that's it for the review. Come see me in office hours if you have questions.